Hello everyone, welcome to Pepcoding. I hope you are fine. We are here today to solve a question, name remove node in Doubly linked list. So in this question, we are given a node and we have to remove that node from the given Doubly linked list. Okay, so let's go and look what the question we have. So here in the code, we are given a partially written Doubly linked list and there is a function for removing that node that we have to complete. Okay, so yes, here this is the function for removing node that we have to complete. This time we don't have given the index. This time we have given a reference node that we have to use to delete that reference node from the linked list. Okay, so let's go on the board and see how we are going to do that. Okay, so we are on board. So just suppose this is the given doubly linked list we have. So we have to delete a given reference node. That is the reference node that we have to delete. Okay, so there are different cases. Just suppose if we are given a doubly linked list with a single node, just suppose this is 3, so this will be head and this will be tail, and we have to remove this node. So after this, what will happen? Our head will equals to null and tail will also be equals to null. This is the first case. Okay, and what is the second case? Second case can be that we have to remove the node that is at the last. Okay, so how we are going to do that? Okay, first of all, how we will check which node we are at right now, like this reference node, where it is. So simply for head, what we can check, like if we compare it with head, if it is equal to head, it means it is the first node, and we can directly compare it with tail also. If it is equal to tail, it means it is the last node. Okay, so doing that will be little extend the question of ours, but what we can do, we can simply take the previous of reference node. If this previous is null, it directly means that it is the head of the node that we have to delete. Okay, and if the node dot next is equals to null, so what it means, it means it is the tail node that we have to delete. Okay, so these 2 points are very clear. Now let's move forward and see what we are going to do. So the second scene, what we have that the reference node is the head node of the given linked list. Okay, so if this is the scenario, then what we will do, let me erase this first part. This was the type 1. What will the type 2? Let's discuss. If the given reference node is the head node, then what we'll do, we will shift the head to the next. So this will be our head, right? And what we will do, we will remove the links, like this reference node next will be equals to null, and the previous of this head will be equals to null. Okay, so and the previous of this node is also equals to null, so this will be done. This is how we are going to remove the node when it is the head of the given linked list. Okay, so let's talk about the another scenario, the third type. Okay, so how is going to be the third type? The third type can be the reference node is our tail. Okay, if the reference node is the tail, then what we will do, very simple, again we will go step by step. We will shift the tail to the previous. Our tail is here. Okay, so this tail is removed. Now after this, what we will do, we will break this link. Tail dot next should be equals to null, and the reference node dot previous should also be equals to null. Okay, so this link is broken and this node is removed. Okay, so we have covered the 3 types here. After this, one more type is left. What is that? Okay, so this was the given linked list. Let's write what we have covered. We have covered if the size of linked list is 1, so head and tail will become equals to null. Okay, this was a type 1. What was the second type? Second type, if head is equals to the reference node. Okay, so what was we were doing when head equals to a reference node? We have seen just here what was happening at that point of time. Head was equals to head dot next, and what we have done after that, we have simply removed like that node, the head node. How we have removed that? We have made the head dot previous equals to null, so that remove the connection of the previous, and we have removed this connection also, reference dot next equals to null. Okay, this is also done. After this, what we have done, if the given reference node is equals to tail, if that is the scenario, what we have done, we have make tail equals to tail dot previous. That was the first step. After that, what we have done, we have removed the tail connection with the next node. So tail dot next equals to null. We have done that. After that, what we have done, reference node dot previous is also equals to null. Okay, so reference node dot previous is also equals to null. Okay, this is also done. Okay, so after doing all this, there is only one type of reference node that is left. That is if our reference node lies between this range. Okay, this is the only type that is left. So how we are going to handle this? Okay, we will discuss this. Just let's write these three part of the code first, because we have discussed that already. Okay, so now let's go on the editor and write the code first. So where is the function? Here. Okay, so now let's see. First of all, we need to check. Okay, let me explain you one more thing here first. Okay, so if we are given a reference node, just suppose this is the node, how we will check that it is the head or it is tail? For that, we can simply compare it, like it is equals to head or not, it is equals to tail or not. But the second method, what it can be, we can take the previous of the given reference node and we can take the next of the given reference node. If the previous is null, it means it is the head. If it's next is null, it means it is the tail. Okay, so it will handle these two scenarios, and it will also help us in future solving question, like if we are dealing with this range also, that we will discuss later. Okay, so let's go. We will find out the previous and the next first. So first of all, node equals to node previous equals to reference node dot previous. Okay, we have the previous node, and one more node we need to find, that is forward. That will be reference node dot next. This is that we have both the node now. Now what we need to check, we need to check that if that is head, that is tail or not. Okay, so before that, what we have done, we have checked the size. If the given node is only node that we have to delete, in this case what we have done, we have made head and tail equals to null. Okay, so we are here. If this dot size is equals to 1, what it means, it is having only one node that we have to delete. Okay, so let's go. In this scenario, this dot head will be equals to this dot tail equals to null. Okay, this what we have to do if the given node is only the node that is present in the linked list. After that, what we have to do, we have to return reference node dot data. Okay, this was the first case that we have handled. After that, what was the second case? If the given reference node is head. So if the given reference node is head, then its previous should be equals to null, right? So let's go and check. Else, if the previous is equals to null, It means it is head. So what we will do in this case? In this case, the first step was to move the head one step ahead. Okay. So this dot head equals to this dot head dot next. Okay, this is done. After this, what we will do? We will break the connections. So what was the connection? This dot head dot previous equals to null. We have removed the previous connection and we have to remove the next of the reference node connection. So reference dot node dot next equals to null. This is also done. And from here we have to return reference node dot data. Okay, actually not data, this is the value that we have to use. So value. Okay, and here reference node. Okay, so this is done. Here we also use data, so we will write value reference node dot value. Okay, so this is also done. Now let's talk about the third case. What was the third case? If the given node is tail that we have to delete. So in that scenario, what we have done, we have shifted the tail to its previous. Okay, so now let's go tail if. So first of all, we have to check it. How we are going to check it? If the next of the given reference node is null, then it means that we are here with the node that is tail. So if the forward is equals to null, in this case what we are going to do, we are going to shift the tail. So this dot tail equals to this dot tail dot previous. Okay, this is done. After this, what you have to do, we have to make the next of the tail null. So this dot tail dot next equals to null. And what we have to do, we have to remove the connection of the reference node with the tail now. So reference node dot previous should be equals to null also. Okay, this is also done. Now after this, what we have to do, we have to return the value of the node. So return reference node dot value. This is done. After this, what case we are left with? Okay, after this we are left with only one case that we have talked about. Our node lies between this range. Okay, so just suppose we have to delete this node. Okay, we will discuss this here. After that we will code this part also. So just suppose we have to remove this node. So first of all, we have already found the previous node and the forward node. We have this. Okay, so what we can do, we can break this link and directly connect this with this. So for this, what we have to do, we have to remove this link. Okay, so the next of previous will be equals to forward now. Okay, so next of the previous will be forward. We can write the fourth case if the node is in between. So what we can do, first thing we can do, previous next will be equals to the forward one. Okay, this is, after that what we can do, we can break this connection, and in the previous of forward we can make our previous. So forward dot previous should be equals to previous. Okay, so this connection is built. Now we just have to break these two connections for the reference node. So what we will do, we will make it null. Reference node dot previous equals to null and reference node dot next equals to null. Okay, so sorry, reference node dot previous equals to null and reference node dot next should also be equals to null. This is done. Now let's go and code this part also. So we are here in the else part. What we are going to do, first of all, we are going to break the connection with the node with the previous and the forward, and we will make a new connection with the forward to the with the previous to the forward. Okay, so previous dot next should be equals to forward. This is done. The second case was forward dot previous is equals to previous. This is also done. After this, what we have done, we have broken the link with the reference node. So reference node dot previous is equals to null, and reference node dot next should also be equals to null. This is also done. After that, we have to just return the value, return reference node dot value. Okay, so we have broken the question in 4 parts and then we have solved it. So this is an easy method to solve this question. Now let's go and run this code. Okay, we have some. Okay. We have some typing mistake here. Okay, now let's run this again. Okay, cannot find this. Okay, in which line? 318. Return reference node dot value. We have, think, give me a second. Okay, value, we have a data here. Okay, data. Okay, so we have data to use everywhere. Also data and also data. At this point also we have to return the data. Now let's run this. So this is successfully accepted. Now let's submit it for all the test cases. Okay, so all the test cases passed. So I hope you have learned something from this video. Please like and share the video and subscribe the channel. Thank you so much.